This is part 2 of the video on this problem. In the previous video, we answered part A, B, and C of this, and quickly recall that we are given a graph of Q prime of X. This matters a lot. It's not Q of X, it's not Q double prime of X, it's Q prime of X, and we are answering the following question. So let's go to part D. Let's go to the next part, D. Which of the following intervals is Q double prime positive? So now there is another important correspondence that you have to know. So this is very important to know, and it's that Q double prime being positive. You should think of this as being analogous to Q prime of X increasing, and this in turn should be analogous to Q of X being concave up. This is extremely important. So I guess if you take away two things from this video, the first thing would be increasing Q corresponds to Q prime being greater than 0, and decreasing Q corresponds to Q prime being negative. And the second fact is that Q double prime being greater than 0 corresponds to Q prime increasing, and this in turn corresponds to Q of X being concave up. So again, to quickly recall any of these notions, remember that concave up means the graph of Q of X. The graph of Q of X looks something like this. It can either look like this, it can also look like this, it can also have, say, like local minimum or something like this. And the easy way to see why these are concave up, or remember why these are concave up, is that when I draw the eyes, all of these are a smiley face. So if you make a smiley face like this, these are all concave up. And I guess it deserves to be mentioned that if I'm making a frowny face, so all of these would be concave down. And one important thing, I guess, that's worth pointing out about concave up is that you can be concave up and increasing, you can be concave up and decreasing, you can be concave up and go from decreasing to increasing. So a lot of different things can happen when you're concave up. So Q of X concave up and Q of X increasing, decreasing don't really have any relationship. But Q of X concave up does mean the Q prime is increasing. And here's one way to think about it. So for example, when I look at this last one, let's see what's happening to the slope. So when I try considering the slope, so maybe slope here is very negative. So maybe slope at this point is maybe negative 100. Consider like maybe this point, the slope here is less negative. Maybe slope here is negative 2. And at this point, we see that slope here is 0. And then maybe at this point, we see that slope is now going high again. Maybe slope here is 10, positive 10. And all I'm trying to say here, when I have a graph that's concave up, when I look from left to right, the slope is always increasing from left to right. You start with negative 100, then negative 2, then 0, then 10 in this example. So we see that Q of X being concave up means the slope of Q is increasing. That exactly means Q prime of X is increasing. And remember, when some function is increasing, when I differentiate this one more time, so when I differentiate Q prime and get Q double prime, that means Q double prime better be greater than 0. So this is the reason that these two correspondences are intuitive. And again, there might be one exception where Q double prime is actually 0, but you're still concave up in a neighborhood. But not really worrying about these kind of exceptions too much. This is really what you really should know. So knowing this fact, let's see how we can answer this question. We want to find where Q double prime is positive. Again, we're given a graph of Q prime, so you want to translate this to Q prime. Q double prime being positive means Q prime of X is increasing. So going back up, we just want to see where it's increasing between 0 to 2, 4, and 7, 9. So 0 to 2, 4, and 7, 9. Let's quickly go up and see which ones are increasing. Well, from 0 to 2, we see that we're increasing. 2 to 4, we see that we are increasing. And 7 to 9, we see that we are actually decreasing. So 7 to 9 is not right, but the other two choices are correct. So let's circle 0, 2 and 2, 4. Let's move on to part E. At which of the following values of X does Q of X have an inflection point? So again, I want to quickly recall what an inflection point is. An inflection point is where concavity goes from concave up to concave down, or concave down to concave up. It's a point where concavity changes. So here you want to go from either concave up to concave down. Again, of course, I'm talking about Q of X. Or you want to go from Q of X concave down to concave up. The picture that you should have in mind, I guess, are things like this. For example, if all of these are Q of X, so of course, if it's like graph of Q prime of X, the explanation changes. But if you are given a graph of Q of X, what inflection point looks like, or they look like these points. So it looks like this point, because to the left of it, you have a frowny face, so you're concave down, and then to the right of it, you have a smiley face, so you're concave up. So here your Q of X is changing from concave down to concave up, so this point is an inflection point. For example, in this one, you see that you have an inflection point around here. You're going from a smiley face to frowny face, so you're going from concave up to concave down. You also have an inflection point around here where you're going from concave down to smiley face, concave up. And for this kind of function, you should also be able to argue that you have an inflection point around here going from concave up to concave down. So this is what inflection point or point of inflection looks like for Q of X, but while we are not given the graph of Q of X, we are given the graph of Q prime of X. So you actually have to translate this. Well, how do you translate this? Well, Q of X going from concave up to concave down exactly means that Q prime of X is gonna go from increasing to decreasing. So again, in case this was not obvious here, of course, when Q double prime is less than 0, that's gonna correspond to Q prime of X decreasing, which in turn is gonna correspond to Q of X being concave down. So if Q of X is going from concave up to concave down, that exactly means Q prime of X should go from increasing to decreasing, or vice versa, right? Or if Q of X is going from concave down to concave up, you want Q prime of X to go from decreasing to increasing. So we just want to check whether any of those are happening. Any of those are happening at either 2, 7, or 9. So let's go back up. What's happening at 2, 7, or 9? Well, at 2, we see that Q prime is going from increasing to still increasing. So Q prime is going from increasing to increasing. So Q is going from concave up to concave up. So 2 is not it. At 7, we see that Q prime is going from increasing to decreasing. So we in fact have an inflection point. Q is going from concave up to concave down, just based on whether Q prime is increasing or decreasing. And at 9, we see the Q prime is going from decreasing to increasing, so we once again have the change in concavity. So 7 and 9 are what we're looking for. So the answer to this question is 7 and 9. The final part is asking which of the following values of X does Q prime of X have an inflection point. So Q of X having an inflection point, we already know what that means. What about Q prime of X having the inflection point? Well, we are literally given the graph of Q prime. So we are literally given graph of Q prime. So all that the question is asking is where does this graph have inflection point? So we don't have to worry about increasing, decreasing, positive, negative. We just want to check where you're going from smiley face to frowny face or frowny face to smiley face. So the points that we have to check is 2, 7, and 9. So 2, 7, and 9 once again. So let's check one by one. So at 2, we see that we are going from frowny face, we are concave down here, to smiley face, you're concave up here. So when I say concave down and concave up, I mean Q prime. This entire graph is concave down to concave up. Q of X obviously is behaving not quite the same, but we only care about Q prime of X here. So this is in fact an inflection point. What about 7? Well, at 7, we see that you're going from frowny face to smiley face. So the concavity is going from concave down to concave up. So 7 is also a point of inflection. What about point 9? Well, at 9, you see that you're really making smiley face all throughout nearby 9. So your concavity is staying concave up in the neighborhood. So 9 is not correct. So the answer to the very last question is 2 and 7.